Alright, this is 2-4, Graphing Quadratics. So our objective today is to be able to graph a parabola from a quadratic in vertex form by hand. This is not as hard as it will feel at first, and I promise that. I am going to do my best to explain it, but again, if you ever have questions, please ask. Email me or come to the study session at 11 on Fridays. I would be happy to help you. So first, we're going to just talk about the most basic parabola, and that is y equals x squared. So this function has it's a parabola, but it has no basically nothing altering it. It's like the starting point from which we get all other parabolas. So x squared, and we're going to look at this graph pretty closely, because once we understand this graph here, what we can do is move it around, and that's really the entirety of this lesson, is understanding the basic parabola and then how to move it around, how to change it so that it will match other functions. So every other parabola, like it says here, every other parabola is just a shifted, flipped, stretched version of that parabola. And we're going to work with quadratics in vertex form because those are the easiest to graph from. So I won't ask you to be graphing different forms of quadratics, just vertex form, because it gives us the vertex and it's super useful. So yeah, every parabola is just a shifted, stretched, flipped version of this parabola. So we're going to really understand this guy well. So the original parabola has a vertex of 0, 0. So its lowest point, its minimum, for being specific, is right there. It's at 0, 0. Its line of symmetry is just right along the y-axis. So you can fold it along the y-axis and it will meet itself. It's concave up because it's not a negative flipped version, so it's concave up. And to get the other points on a parabola, so this is the valuable part, is knowing where to put points so that you can guide your U shape to be the right U shape. So we're going to look specifically at these 2 points. Those are like nice crossing points where that parabola crosses like a very simple point, and then these 2 points. So altogether that's 5 points. That is plenty to graph a parabola. If you were graphing more than 5 points, I mean, you can if you want to, but these 5 points will give you all the information you need to graph the entire parabola. So, and again, parabolas are symmetrical, so if you can figure out where 2 of those points are, you can figure out where the other 2 are. If you can figure out where these 2 are, these are just going to be reflected across the y-axis. They're just going to be the same on the other side of the line of symmetry. So those points specifically, you start at the vertex, right? The vertex is at 0, 0 on this basic parabola, and then for the first point, you go over 1, up 1. And that's the same on both sides, over 1, up 1. So the first 2 points are over 1, up 1. And then this one is -1, up 1 because we're going back 1. But again, it's symmetrical. So if you can remember just like this half of this table, you can remember the other half. For the second point, we go over 2, up 4. And that will look like 2, 4. So I am going to put little arrows on these because they're points. On this parabola, they're actually the coordinate points. But if we were to move this parabola, if we were to move it just like, not stretch it, but just shift it over somewhere, then we can find the other points by just finding the vertex and then going over 1, that's my little arrow, and then up 1. The second point I can find by going over 2 from the vertex and up 4 from the vertex. Same thing for this one, we'll go left 1, up 1, and then left 4, which I'll write as -4, up 4. Oh, not 4, sorry, this is 2. So on both sides of these parabola, we first go over 1, up 1, and then over 2, up 4. So again, if you can remember this half of the parabola, you can remember the whole parabola because they're the same on both sides. So start at the vertex. This is your starting point. And then you go over 1, up 1, and over 2, up 4. That will change into down if it's a concave down parabola, and we'll talk about that in a second. But then once you have those points, you just copy it onto the other side of the line of symmetry, and you are good. So graphing parabolas is just a matter of remembering over 1, up 1, and over 2, up 4, which is where this is coming from. We go over from the vertex, that's the starting point. You go over 1, up 1 to get 1 point, and then over 2, up 4 to get the other point. Yeah, and every parabola that's not stretched at all will be the same. So it'll be over 1, up 1, and over 2, up 4. When we stretch it, it starts to look a little bit different, but no more difficult, right? We will learn how to do that. But if we get super familiar with this, we can graph any parabola, and that's real. So I'm going to take a break from this. I know I don't usually do this, but I'm going to take a break from the notes, and I'm going to just show you on Desmos, sort of some transformations and what it looks like when we move stuff around. And just to, as a quick reminder, and I don't have a pointer on this, but this table, this function that's displayed right there is in vertex form. And remember that this vertex form has h and k. Wait, let's go back. I can't do it when I'm not pointing it. Okay, there we go. So this is the form that we're working with. And remember that these two give us the vertex, h and k give us the vertex, and then this is the stretch value. So on this Desmos graph, what I'm changing here with my sliders is this is changing the a value. When I change the a value, it either gets to be less than 1, it gets squished more. And when I change it to more than 1, it gets stretched. And I'm going to really quickly, well, actually, I'll come back to that because I'm going to leave it at 1 because that's no stretch. And then we're going to talk about h and k. So when I move h, notice that the parabola shifts left and right. And again, this is opposite sign. So if I have a -5 in my function, it's over to the right 5. And if it's a negative, it's notice that I have a minus and negative. So in a normal function, that will look like +4. So if you have +4, it'll be to the left 4. So we're just scooting those 5 points over left and right with h. And with k, we're moving it down or up. And these are the same sign. So we just shift it down or up, however many. So if I leave this at +4, I've just moved all of those points up 4. And really the way that I want you to do this is to graph the vertex, and this one is going to be at 0, up 4, and then graph the other points from that vertex. So you would go over 1, up 1, and then over 2, up 4 to get the other 2 points of the parabola. So really all we're moving is the vertex. And notice that down here I have, if we move, well, actually, let's talk about stretch really quick. So I'm going to stretch this by 2. I'm just going to leave it by 2, and those blue points on this graph are the original parabola, so we can sort of compare with the original parabola what this new one looks like. If our stretch factor is 2, those points are no longer over 1, up 1, and over 2, up 4. Instead, this one is over over 1 up 2 over 2 up 8. And I will say that again, it's instead of being over 1 up 1, it's over 1 up 2, stretch factor of 2. And instead of being over 2 up 4, it's over 2 up 8, stretch factor of 2. So that stretch factor, what it does is it stretches how much we go up by that amount. So we're just multiplying the up part by whatever stretch factor we have. So that's where the 2 came from. Instead of going over 1 up 1, we're going over 1 up 2 because we've multiplied that up value by 2. Same thing for over 2 up 4. Instead of doing over 2 up 4, we're going to be over 2 up 8 because we've multiplied that up by 2. Hopefully that will make more sense when you start looking at graphs. I promise this is not as bad as it looks. The other thing I'm going to do is change this to be a squish, which is I'm going to change it to be 0.5. And so this is just some further evidence of what I was just saying. If we have a stretch factor of 1/2, instead of going over 1 up 1, we're going to go over 1 up 1/2. And instead of going over 2 up 4, we're going to go over 2 up 2 because 2 is half of 4. So we half the value that we go up. And that works for any fraction. If it's 1/3, then you third the value you go up. So we can't be super specific about thirding things, but and you probably won't see that on ones that you need to graph. On MathSpace, the only ones that it requires you to graph are the vertex and then one of these other points, either this one or this one. So really all you have to remember is that you go over 1 up whatever your stretch value is, because multiplying stuff by 1 is just itself. So you go over 1 up the stretch value. Hopefully this will shed some light on what we're about to do. Basically, we're just changing the standard parabola to be a little bit different. So we're moving the vertex, and then we're maybe stretching it or squishing it. Yes, I like the word squish better than compress. Don't ask me why. So, oops. So here is a shifted parabola, and it's shifted like we don't have any numbers here. We are just having, oops, we have A, H, and K instead of numbers there, because I want to just highlight the fact that we are just plugging numbers in. So on this parabola that's shifted H and K and stretched A, the vertex is going to be at H comma K. We know that already. Let's do this. For the vertex, you go over H and then up K. That's for our vertex. The line of symmetry is where the vertex is, so that one's not super hard. It's x equals h. Concavity, if the a value is positive, it's concave up, or if it's negative, it's concave down. I'm looking over here. Obviously, this graph here that's like graphed is a specific function, and I'll tell you what it is later. But obviously, this a value is positive because it's concave up. But then from the vertex, once you've found H and K and graphed that point, from that point to find the other points, you go over 1, and then up whatever A is. And then for the second point, you can go over 2 and up whatever 4 times A is. Because remember, our standard parabola was over 1 up 1 and over 2 up 4. And we're multiplying those up values by A. So this one is really like 1 times A, and the other one's 4 times A, but we don't need that one. So the stretch factor, which is A here, hang on. We're gonna do some more highlighting. A is the stretch, H is the left and right shift, and K is shifting up and down. So this is shift up or either up or down. I need a pink marker. H is shifting left and right. And A is the stretch. Stretch, compress. You can put squish if you want to. And then concavity. So we stretch it. Hang on. I need my blue marker again. So we stretch it. There we go. We stretch it by A. And this specific function, so notice I have this table again. H and K is where you start. This is the vertex. Start here at the vertex. And then to find the other points, you go over 1, up A, and then over 2, up 4 times A. And then just copy it to the other side of the line of symmetry. This specific function, notice that we go over 1 up 1/2 to get that first point, and then over 2 up 2. So that tells me that instead of, because I start with over 1 up 1, we're going over 1 up 1/2. That means that the stretch factor, and I'm just going to start with my normal formula here. The stretch factor must be 1/2 because I'm going over 1 up 1/2 to get that first point. And then we have x, and we moved it 2 to the right, which makes you feel like it should be +2, but really it's -2 because that's the opposite sign. And then up 1, which is a +1. So this specific function that's graphed here is actually 1/2 compressed, right? And then it's at +2, +1, which gives it that vertex right there, over 2 up 1. So let's try this. I know this stuff is brand new, so if you're still reeling, don't worry, you'll get it, especially if you ask for help. So here's our function. I'm going to highlight again our vertex. That's not our vertex, I mean our stretch factor. That's our A. And then here's our H, and then here's our K. There we go. So our vertex is at +1. Hang on. +1. -4. That comes from the H and the K. Remember this one is the opposite sign. Whoops. We talked about that when we took notes last time. This one's the opposite sign. This one's the same sign. So that's our vertex. Line of symmetry is just x equals whatever the x value of the vertex is, which is 1. The stretch is -2. And it's concave down because it's a negative. So I'm going to start with this little table right here, and in the middle I'm going to put the vertex because that's like our starting point, and my vertex is at +1, -4. And then from that point we go over 1 and then up the A value. So when the A value is negative, that means down. So we go over 1, down 2. And then over 2, because we're stretching it by 2 again, we're going down 8, because normally it's 4. But this time we're doing twice as much, which means it's down 8. Interesting. I was just looking at my notes. Again, the notes have errors in them. that's attached below this. I think that my original notes had a +2 stretch value, and it's now been changed to a -2. I can't be super clear about that because I can't tell. Oh, maybe it's because, that's why. I'm gonna think for a second. Because my graph over here doesn't fit our function very well. You know what? Doesn't matter. We're gonna roll with it. So I'm gonna start with my vertex is at +1, -4, which is right here. And then from that point, remember, from that point, we go over 1 and then down 2. This is why I changed it to be a positive. Because we can't even fit the over 2 down 8 on the graph. I'm just going to copy this point to the other side of the function, over 1 down 2. And then our nice tiny little parabola that we can fit on here looks like this. So that's why I changed it to be positive. That's what happened, but I'm not gonna worry about it. So you start with your vertex and then go over 1 down 2. We can't fit that other point, and that's totally fine. This is as good as we can get. It's a negative concave down parabola. So let's do the same with this one. Our vertex, let's write this first. Oops. Line of symmetry. Highlighting, this is our H. Nope, that's our H. I just said that backwards, but I highlighted correctly. 3 is H, -1 is K. A +4 is our stretch factor. So our vertex is going to be at -3, opposite sign, remember, and -1. And our line of symmetry is just at x equals -3. Our stretch factor, our stretch is a 1/4, which means it's going to be a 1/4 as tall as it usually is, and it's concave up because that a value is positive. So I'm going to start with this table again. My vertex is at -3, -1. And then from that point, I'm going to go right 1, over 1, and up a 1/4. Because normally it's 1, but since we're compressing it to be a 1/4 of the size, we're only going up a 1/4. And then over 2, up, usually it's 4. That's our standard is 4. But since we are doing a 1/4 of that, it's only up 1. So normally it's 4. I'm going to write this. Normally 4. So 4 times a 1/4 makes 1. That's where I got that. And both of these are up because of the concavity is up. And this is just copied on the other side. So we're going to start with -3, -1. That's where our vertex is. And then from that point, I'm going to go over 1, up a 1/4, which honestly is not super easy to tell where that is on our graph, and that's fine. Doesn't need to be perfect. Same thing on the other side. We just copy it on the other side of the function. And then for that second point, we go over, I'm going to do this in pink. We go over 2, up 1. And same thing on this side, over 2, up 1. I'm just following my driving directions right here, over 2, up 1. So this is a compressed parabola. It looks more like, let me get a different color so that I can see my points still. It's a compressed parabola, which looks something like, whoop, a little bit too straight. There we go. So it's sort of a smashed U shape instead of, as opposed to this one is pretty steep. That comes from that 1/4 stretch factor. It's compressed by a 1/4, which is what gives it that shape. So these last three, what we're doing here is comparing two graphs. two functions of different parabolas, and we're identifying what changed between them. So for this first one, we start with y equals x minus 1 squared, parentheses squared, minus 3, and we are, the transformation here that's happening is now it looks like y equals x minus 1 squared plus nothing. So we went from having minus 3 to having plus 0 at the end. So that transformation is actually moving it up 3, because we started, the first parabola there was at down 3, and now it's not down 3, it's 0. So we have moved that parabola up 3. So because this is where it started, and we moved up 3 to get to plus 0. So that's really all it wants, is just the directions. It has shifted, maybe I should say that. It has shifted up 3. For this next part, our original parabola, I don't know if I want to say original, but the starting parabola has just a 1 stretch factor, because that's just assumed. And then it has changed to have a 2 stretch factor, which means that going from one to the other, we stretched by 2. And the other thing that changed is that this became a 2. It used to be minus 1, and now it's 2. Remember that value is the left and right shift. So it used to be shifted right 1. Now it's shifted right another 1. It's shifted right 2. So we have actually changed the original parabola to have, we shifted it right 1 more space. Honestly, if it helps you, graph these. It might just be more work, but also if it helps you, that's worth it. Okay, here's an interesting one. Clearly this wasn't here before. We used to have plus 0 in there. And then we have this minus 4 on the outside, which changed into be plus 0. And those are the two things that changed. So again, the pink stuff is left and right shift. So we started with no left and right shift, and then we shifted it right 1. So we know this went right 1 from this transformation. And then this transformation, it used to be at negative 4, now it's at plus 0, so that means it shifted up 4. There's just a few questions like that on your homework, where you're looking at a parabola and you're looking at another parabola and you're seeing how it changed. Feel free to use Desmos, that program that I just showed you. It's useful, I just don't want you to depend on it for everything. I want you to know how to graph parabolas by hand, because that's what will be required of you on test and also on the ACT and that sort of stuff. So I want you to know what they look like pretty intimately, but once you get to these transformation functions, you can use Desmos. So that's my recommendation, and in fact that's actually all the notes for this unit.